Okay, this is lab 5, experiment number 4. In this particular lab, we are going to take 3 compounds and mix it and then separate them. The first compound will be cobalt chloride. The second will be sand, silicon dioxide, and the third will be iodine. What I'm going to do is we're going to look at the chemicals closely, and I'm just going to pour some of these chemicals into some weighing paper so that I can take a close-up view of what each of these chemicals look like. So please write down your detailed observation of what these things look like based on the video. That is cobalt chloride, and it's actually cobalt chloride hexahydrate. So the cobalt chloride is actually cobalt chloride hexahydrate, and you indicate the hexahydrate by adding 6H2O. This is sand. And the last one is iodine. Now the amount of iodine that I have here is too much. All I really need is just one piece, and that one piece will be probably about that size. Okay, so I'm going to take a beaker. Sure, it's a clean beaker. What we're going to do is we're going to take all 3 components and mix it in the beaker. So for the iodine, all I need is one piece. That'll be this piece right here. I'm going to put the rest in the bottle so that we don't lose it. Then I'm going to take the sand, and then I'm going to add the cobalt chloride hexahydrate. I'm going to make some careful observations. And that's simply just taking this mixture and zooming in on it. And here you can see that there's one piece of iodine here, cobalt chloride clusters, and then the sand. Here's a side view, what it looks like. This mixture, and zooming in on it. I'm going to take this, and then I'm going to take an evaporating dish. Make sure that the evaporating dish diameter is smaller or bigger than the beaker so that it doesn't drop in. Then I'm going to put a little bit of ice on the evaporating dish so that there's a cold surface at the bottom. Next, I'm going to heat the mixture over a hot plate. And just going to make some very careful observations as this process takes place. So just going to look at that. And then what we're going to do is we're going to pay attention to the crystals. I know that that right there is iodine. This is cobalt chloride, and then sand. And as this hot plate starts warming up, what will happen is that one of these chemicals will be separated by the heat, and one of these chemicals will sublime. So we're going to go ahead and wait for this to warm up. And again, careful. It's important to make very careful observations. Now if you look real closely, you'll see that there's some gas forming, some purple cloud forming. Please note where the gas is forming, which compound is generating that. That's part of your lab. As the chemical starts to sublime, sublimation is when a solid turns to a gas. You notice the gas swirling in there, and then it's going to collect on the bottom of the evaporating dish because that's a cold surface. You can see at the bottom of the evaporating dish, that's where the purple gas is going to accumulate. And when the purple gas stops, then this procedure is done. It's important that you have a cold surface. That way the gas will reconvert back to a solid. That's the sublimation process. You notice that the purple gas has stopped forming from the bottom. That means that that particular substance has completely sublimed. Now it's in the gas form. And if you look at the bottom of that evaporating dish, you're going to see some gray material starting to collect. So we're going to let this go until there is no more purple gas at the inside the beaker. So if there are hardly any purple gas, we're going to go ahead and move this to the side. We're going to remove the evaporating dish, and then we're just going to invert the evaporating dish so that we can see the bottom of this evaporating dish. The purple gas has accumulated towards the cold surface of the evaporating dish, and now that's where it is. If we take this, you can see that you can easily wipe this, and that's what the texture looks like. So we're done with this particular procedure. This is separation of chemical A. The next thing we're going to do is we're going to go ahead and take the mixture left behind. This is B and C. I'm going to set this aside. And we're going to add water to this. And I'm just going to do a minimal amount of water. Then I'm going to swirl it so that everything dissolves. At least the component, one of the component is completely dissolved. If I'm satisfied with that, okay, I'm going to add a little bit more water. Swirl it. Make sure all the component that's soluble in water dissolves. The next step in this procedure after adding water to components B and C is to decant the liquid into another beaker. While the third component is left behind. Okay, I can wash this a little bit. Make sure I get all the residual chemical that dissolved in water, and I'm just going to decant. This is the decanting process where you pour the liquid off from any solid residue left behind. So this first component over here is A, that's B, and this dissolved in water is C. What we're going to do with C is we're going to heat it up and evaporate the water. We're going to heat up the chemical identified as C and evaporate the water. And as the water starts heating up, the solution starts heating up, the water will form steam, and that's basically the gas that you see. notice the color of the solid residue that remains behind. When all the water has evaporated, this is what the component chemical C looks like. We're going to allow it to cool off a little bit, and then we're going to add water. So it's like after adding a few drops of water. So I'm just going to add some water off to the side here. Now you can see what it looks like as that chemical absorbs some water, and what the color looks like. Go ahead and add some more water to this. So now you can see the form in which chemical C has no water. That would be the blue, purple, versus the form that does have water, which is sort of violet. And again, these are the chemicals that were separated during this experiment via sublimation, via insolubility in water and decantation, and that one through the evaporation of water. And these are the original chemical: cobalt chloride, hexahydrate, sand, and iodine.